So, welcome to episode 3, which I have just updated our shared notes with as out of hibernation. So, we started out
That's
strong.
accurate.
We had a good run. I think when we had low projects, tasks saturating us at work and low life stuff getting in the way. And then, bam, life happened, of course. I had kind of a serious death in the family. And then, following that, Dell was out for a little bit on a journey to meet up with a friend, and then we just kind of got off the tracks from there with other life things. So yeah, but here we are back again. This episode is going to be a pretty light one, just kind of like I said, getting back on track. We're going to be talking about just some personal fun projects that we're working with, and maybe a glimpse into some things that are going to be coming down the pipeline in future episodes, and talking about some other news, mainly really Ben Eater's video, which was awesome. He recently produced another one the other day, but don't want to get too far ahead of myself. And then we'll recap the last show and set ourselves up for the next one. How's that sound, Dell?
Classic Aaron. Sounds good to me.
Right. So, in I guess the kind of first segment here for personal projects and fun news, me personally, I've been getting back into playing around with some SDR. We've had some back and forth on projects with that at work as well. Unfortunately for me at home, I do not have the prosumer kit. So, right now, I've been messing around with the ADALM Pluto PySDR. Awesome site over there at pysdr.org. And on it, really takes you through like cradle to grave. If you've never really done anything with software defined radio before, but you do have a programming background, it could be a great place to pick up, one of those lower cost SDRs and go through. There was a bunch of little nuggets that I've picked up actually too that I hadn't known about before. One of which is a particular type of formatting that you can save files into called SIGMF. Been checking that out, and the reason that I've been checking out SIGMF is because in addition to playing around with some SDR, we also came across something else called Dear I'm GUI or Dear Im GUI. I'm not necessarily sure exactly how to pronounce it. What that
M
is,
said I think it's MGUI.
Im GUI, I'll go with that. Uh,
I feel like this is the same as the age old like Imager. Like what is the name of this thing? I think the
what's
moral of the story is in the README, put how the fuck to pronounce it.
yeah, or I mean, even if you do the same with GIF GIF, even when the person who creates it comes out and weighs in one way, people are still saying, "Well, they're wrong. My way is the right way," and you get the connotative and denotative meanings of words. And yeah, so what is that? It's a pretty cool, like relatively bloat-free, like a graphical user interface library for C++ that allows you to prototype pretty quickly in the graphical space. Anybody who has ever spent any amount of time in Visual Studio or something similar, creating your form and dragging the elements around and understanding the Win API and all of those things, knows what a pain it can be. A lot of that is, you still may have to encounter some of it, but a lot of things are kind of abstracted away. And really, it's got a ton of different render agnostic code in there as well, so that you can tie it into one of the better defined graphical environments out there, whether that be DirectX or whether that be what are some of the others? Do you recall off the top of your head?
Oh, so DirectX and OpenGL are both supported, as well as it's SDL, which is the one that I always wind up using, and a couple of other things that I don't remember the name of.
So primary use case really for it, I think, is in really the video game world, right?
It does have a lot of use in the video game world, at least on the wiki anyway, or not, excuse me, not the wiki on GitHub. It definitely lists quite a few games. It seems like it's in a lot of places, and it's just kind of hard to pick it out. I think they listed some pretty serious software there as well.
Right. And
Let me
regardless of what its main use case is, it's a light graphical user interface environment that you can pretty easily program to. So my mind instantly went to some of the stuff we've talked about in previous episodes, one of which would be kind of like your own decompilation visualization tool. Another would be a general framework for doing emulation stuff in, both kind of, I think, at work and outside of work. There's been a strong push to be able to have a cohesive list of tooling which would allow you to dynamically test some code and not have to look at everything statically. Because man, dynamic testing takes you places way faster. than static
Yeah.
alone.
Yes, it does. Yes, it does.
And so there are some great things out there. There's certainly like Capstone, which we've talked about in previous episodes just a little bit. We haven't thrown up any demos or anything like that for it. And aside from Capstone, of course, Unicorn and all of those other engines and things like that, QEMU, all of those are great. But sometimes, I'm probably going to talk about here a little bit more later on in the episode, sometimes, man, you're really just nice to do your own thing. But anyway, so as we were playing around with SDR, it would be interesting, I thought, to have a GNU Radio like program too that would be compatible with SIGMF. Why would SIGMF be something that somebody would care about or want to know about? Well, when you are recording IQ samples from your radio, all of the different radios that are out there can store those in different formats. And so when somebody else is trying to pull it into their analytic or visualization tool, if they don't know how many bits, for example, is represented in your I or your Q, and you haven't denoted that or written that down anywhere, it's kind of going to be a bad time for them to sort that out. They shouldn't have to. So that's what the SIGMF framework is for, is to be able to say, hey, this is stored as a 32-bit I, 32-bit Q. This is how long it is. Here's some additional information about how it was sampled, the sample rate, and stuff like that. Dylan and I have been playing around with some of that, some of the MGUI framework, and then in addition to the SDR stuff, still playing around a bit with the Paranoids badge, which I said that we would get to, and we certainly will. And then been on the great hunt for different consumer electronics to go out there and grab so that we can pull them apart and talk about some of the things that we run across along the way. The most recent one is this old HP desk jet that somebody was getting rid of at work. I know you've had some experience with tearing some printers and stuff down in the past, Dell. What do you typically find in these
Yes, I
guys?
have. So you're gonna have obviously there's gonna be some control hardware in there. Like there'll be a micro usually of some form. What era it's from and that sort of stuff is gonna depend there. There's almost always a stepper motor, at least one stepper motor, sometimes two, depending on how they like to do their paper feeds. But basically, in my experience, the print head is always moved with a stepper motor at a minimum. You're also going to find some just 8 millimeter steel rod, which doesn't seem like much, but it's pretty common. And I know, like in the early days of building 3D printers and stuff, it was really common for building 3D printers and like small desktop CNCs and things like that. So you can get those weird round bearings for them, right? The cylindrical bearings that you can get for 8 millimeter stuff, pretty cheap and easy. It's kind of ubiquitous. What was some of the other stuff I found in there all the time? Lots of like sensors, like optical sensors. So either optical rotary encoders or I usually found a couple of like optical in-stop style sensors, right? So it's just it's got kind of a U shape, and something slides in there and breaks the beam, and it changes the signal on the way out. You're gonna find some belts and gears and stuff. Those usually aren't too terribly useful in my opinion or in my experience. Also, if you want to rob capacitors, there'll be some of those in there. Connectors, I don't know about nowadays, but back when I was taking them apart, which I guess is like the 2010 era, those USB B connectors, that big kind of square-ish looking guy, you could get some of those off pretty easily. So that's kind of the stuff that I usually wound up tearing out of them. I'm sure there's probably some more to be had in there, but that was the stuff that was always the most interesting to me.
Okay, yeah. Look forward to tearing this guy down too, and I'm sure we'll be talking about it when we do. And then if there are any interesting things that we can try to get at, which there most certainly will be, we'll probably include those on the show too. But that's kind of the sum up of things that I've been working with. What do you got going on in your neck of the woods still?
Well, so I've been working SDR stuff as well. I have been working most recently is there's an operating system that's getting semi-popular, I'm going to call it, for replacement for the old CentOS stuff, which is Rocky Linux. I've got a Rocky Linux 9 box that I've been working on. Some of it's some software stuff from work that I'm not going to talk too much about, but right now the big trouble there is getting GNU Radio built for it. So for some reason the Qt QWT module or add-on, or I don't know what you call it, library, isn't liking being found very well. So it wasn't in the repository, so I had to build it myself. When I did build it myself, it's in a weird directory, so CMake can't find it. So GNU Radio will build, but it will not build with Pi Qt GUI, which makes it, I don't want to say 100% worthless, but near 100% worthless.
Yeah.
I don't really want to do it completely without a GUI. And I like to play with some of the software there, and that's the kind of the big stuff that I've been working on lately. I've been playing, I think, too many video games. The game Grounded lately, I've been playing like it's going out of style. I've been getting my 3D printer out and going a little bit, so I've been printing. My son likes to build bridges with train tracks, like those wooden train tracks.
Yeah.
And on Thingiverse, I found a guy whose name I do not know and will probably never look up. But what he does is he has this thing. It's like a adapter from that like Brio, however you say it, style train track, like at the top of a bridge, and then you can connect mega blocks to it underneath, so you don't have to like precariously like
Yeah, just prop it up there and have it
balance it on those
crash
little
down.
blocks or some other stuff.
Yeah. Yeah, bad
Yeah,
times
so
as
you
a
can put
kid.
mega blocks and stuff underneath them.
Very nice.
And my son's been loving that, which I also like because then he's playing with mega blocks and stuff too.
Yeah.
What else have I been doing? Watching Ben Eater's video, like you were talking about. That's pretty much it, man.
Yeah, begin to that next. I would say that on the SDR side too, I think you've definitely dug much deeper than I have at trying to do some of the visualizations of both like ADC stuff as well as your own like rasters and waterfalls and stuff like that.
Oh, I was gonna say I did get something relatively okayish working in Qt, right, with C++,
Yeah.
maybe Python. I don't remember. I'll have to. Oh, it's C++ for sure. Think about it. Anyway, that's not important. Yeah, so I did get something there. You could set the width and stuff like that, and it'd be okay, and it'd look all right. I didn't get too much into controls. I switched over to trying to use MGUI. The trouble with MGUI is that it assumes that you are much better at C++ than I am. So it's got a lot of stuff where it's like stuff will be declared, right? Like it'll be a function. It's like, oh, this is the function for doing this thing. And it's just a type def. The function is never actually implemented anywhere. They're just like, yeah, it's your job to make a version of this that'll work. Good luck. And so it's been kind of a pain and a bit of a learning curve for me on that front.
Yeah, it's a little less I guess you could say sequential. It uses a different model where there's a lot of things that are going on in state in two separate and kept track of in state in two separate locations or more at once, and then you have to of course sync over those. So if you want to do something particularly complicated, you could run I think into some hot water pretty quick. But for most menu type things, or I've got my data over here, I just want to pull it in and I want to visualize it, or I want to do something with it and have that available to a person to manipulate on the fly, I think it's a pretty good tool. But the main
Oh,
point that
without
I
a
was
doubt.
bringing up with it too, for at least why we're doing that, is the other point that you brought up, which is that GNU Radio is moving more and more toward having to bring your own batteries as well. So if I'm having to bring my own batteries to begin with, maybe I want to build my own thing.
Yeah, so my huge gripe, and I'm gonna go on my fucking GNU Radio gripe here,
Let's hear
is
it.
the removal of the PSK DMod, right? So it used to have
Yeah.
some PSK mod and DMod stuff that were all relatively simple, and they weren't good, right? They weren't great by any means, and they were kind of good, and they could get you in the ballpark, and you could get a lot of stuff done, especially with the PSK DMod. And I don't think that's what it was called. I think there was another name for it, but it was kind of an all-in-one DMod block for PSK. And I think in 3.9 they deprecated it, and in 3.10 they'd taken it out. And I remember I was reading on something. I don't remember if it was in their issues or whether it was in like that mailing list thing that I hate read through or what it is. And I remember somebody. I don't know if it was somebody from the organization or just another user was really snotty about it. Somebody was like, "Hey, this is like a really good general purpose thing. Like, I'm not against having the other stuff, but why not like just leave this in there?" And like it was kind of just like somebody came in and they're like, "Yeah, like that thing wasn't good, and you should model it in Octave or MATLAB or something." And frankly, if you don't know how to do that stuff, then you shouldn't be doing this anyway. It's like great, but like that's kind of what people are here for, right? Like if you can like chances are if you're modeling what your receiver should look like in Octave or MATLAB or whatever, that you're probably not sitting down and then using GNU Radio. You're probably using
Absolutely not.
MATLAB or just
Yeah.
writing some shit yourself.
100%.
Right?
100%.
So like I don't know. I felt like whoever that was a dick about it, and I felt kind of like GNU Radio's been pushing that way for a while now, where it's like, yeah, we're gonna take out some of the generalized easy stuff that got people introduced, and they're just like raising the learning curve a little bit, but with the same functionality. Like
Right.
that's
So
my random 2 cents on the GNU Radio rant, I guess.
yeah, I would love to get something more, I don't want to say handholdy, but I do want to have something a little bit more accessible to people who have some programming experience and they're stepping foot into the SDR space, which I've always seen or had seen up to this point, GNU Radio being the salve for that itch. But you had mentioned as time's gone on, they just are going to this more generalized purpose framework. So anyway, maybe we'll make something. Maybe we'll save the world with some new tool out there. Probably not, but it'll be fun along the way to get into some of the business that we typically get into when we go down and investigate those deep rabbit holes.
Oh,
But
I
anyway,
definitely agree.
in any event, though, that's a good segue, I think, into the next topic too about people out there who are doing great things and then sharing that with other people. Man, do I love when somebody who is just an expert in their domain, when a Joe Grand or in this case Ben Eater gets out there on their YouTube channel and does a breakdown of something and shares their process along the way. And so what am I talking about here? Well, Ben Eater recently in the last few days had posted a video out on his YouTube channel about the TV Guardian. And the TV Guardian is like a foul language filter that you can put, hook up to your TV. What it'll do is substitute out, bad, some list of naughty words for you. And they don't describe to you what those are, but it'll sub those out for you so you can have more of a G or PG, experience when you're watching television.
I don't know if it bleeps the sound too.
So he doesn't get into it in the video, but he does point out some of the elements that could be used for audio. I don't think he got to the point where he's actually trying to pull the flash off the micro yet, anyway. Or he
I don't
didn't get
know.
into any of those additional chips that he'd pointed out early on in the video, which could be responsible for that, but certainly for like closed captioning.
Yeah. Well, and see, and that's what I was wondering. And I don't know. I don't want to get too far ahead, but when we talk about how it works, I'm curious if it bleeps the sound too, because I didn't see anything about that in there, and I don't know enough about this glorious piece of hardware.
So if you go out there to their, I think, modern website now too, because I wanted to see if they were still around as a company, they do still have like more modern products too. Ones that are like a set top box and can deal with both like satellite as well as streaming services and things like that. The model that he was using, though, I believe was a much older one that you'd use with like a CRT TV, maybe a couple
Yep.
decades ago. And so when you do
Uh,
have a lot of those older devices as well, chances are they don't have the kind of mechanisms in place that would prevent a snooping hacker going around in there and pulling things apart and getting after them. Or they weren't fabricated to be so small that you need special equipment to be able to get in on some trace or pulling off a BGA versus just like a SOIC 8. So in that video, then he goes on to investigate, talking about some of the different pieces with it and just generally saying, I think this is what that is. It's a great look into the process, I think, of what someone does when they're REing, a hardware device. They get a lay of the land and then they look for flash or they look for an interesting thread to pull and then pull it. In this case, he had a little EEPROM on there, I believe it was, that he saw was connected over the PCB to the MCU, and he thought this would be a great first thing to take a look at. Now the thing with Ben is that he definitely has the kit to be able to just pull that flash memory off directly, but he does something that I think is even cooler, which is he reads the data sheet for the problem and shows, okay, well, based on how the data sheet says this should be configured, if the word should be this wide or that wide, it's pulled to ground. So then I know that when I'm pulling this memory off, it's exactly this wide. And when this other pin is pulled to ground, I know that it means that it's write only. So, I'm sorry, read only. So that means that this isn't going to be something that the MCU is writing data to and from. It's only going to be something that gets read. So what's on there? And then he uses an Arduino and kind of programs on the fly. So then he reads the timing diagram to be able to say, I need to be able to wait this long before I send out a read, and I know that I can get so many bytes of information back during a read cycle. Programs that all into the Arduino, does a small test run to be able to see if you can get just a few hundred bytes off, and then eventually pulls it all down. after he gets it all down, he starts to realize, just taking a look through things, that there are some of the naughty words in there. So then, something else, if it wasn't only already interesting that he had used the Arduino to be able to pull that down, he starts taking track of all of the bytes that are coming off of that prom in an Excel spreadsheet and trying to account for what the other bytes might mean. And him, man, his Excel kung fu kind of blew me back. What did you think about seeing that when you saw it the first time?
I was not even fucking remotely prepared for how good he just randomly was at Excel, right? Because I felt like I've been called the Excel guy in a few places before, knowing my basics and things like that. And golly, he was just knew about this stuff, right? I had no idea there was a binary to decimal. I had no idea there was a bitwise and, right? Like there are all these functions that he's using. Is like I just didn't know that they existed whatsoever, and he's just using them like it's everyday business. I'm like, what do you use Excel for over there, man? Like, what's your primary use case these days?
Yeah, I feel like if it was me, I would be taking those things in a big laborious process where I'm, tabbing them out or somehow separating them inside of like a normal flat text file using Python or something to try to answer some of those questions. If I'd even noticed the same types of things that he had noticed, for example, some of the additional bytes, meaning that one was going to be a substitute for the other, or knowing that some bytes actually, like, it was kind of like mapping what the clean word would be to the dirty words. And so to watch that all kind of play out, and then at the end there, he still had some unknowns. So he asked, threw it out there generally to the community if anybody had some insights that he wasn't picking up, then yeah, feel free to share them. But it captured, I think, a lot of different things. It captured the spirit of learning and doing something like that, and then sharing the experience with others, kind of creating that community. And then, man, we talked about it a little bit earlier with MGUI, but we didn't wax philosophical about why you should do it. But I think there's a really great part of, man, which I'm not sure which episode, I'm sorry, I'm not sure which issue it was off the top of my head, but there's an early on proof of concept or get the fuck out that talks, the name of it is a parable of the importance of tools or building your own fucking bird feeder. And so in it, it's a small little passage inside of one of the earlier episodes, but the point being is that sometimes somebody's going to say something like, why are you building your own hex editor? There's, IDA, there's O10, there's this, there's that. But sometimes you just don't have the tool to do the job that you're doing. And sometimes you feel you don't really understand it until you build it yourself. And man, does that video nail, I think, the spirit of that.
I think it definitely does because, additionally, there's a couple other things that have happened to me as I've been trying to build various things or work on various projects. And I did something similar once for reasons completely unknown. I had a PlayStation RAM chip, um, right? Which I think is a Sanyo. Well, whatever. And I had done something similar. I found an Arduino or had an Arduino and wired it all up so that I could test it. It was an Arduino Mega, and put data into it, got data out of it, so I could test and make sure everything was working okay. And I don't remember what I needed to know that for, but it was really like I'd read timing diagrams and stuff like that before, but it was probably the first time it really dawned on me, or really felt like it sunk in, like timing diagrams and how they work and why they're important and stuff like that. Is like, ah, yeah, this is probably just for chip makers. Like, your processor or whatever is probably just going to talk to this thing, however, but knowing and understanding that stuff is definitely helpful, especially when you're going to start troubleshooting and you're working with really fast buses and things like that, and stuff's coming in slightly out of time. He talks about something in the video, and on that, he talks about something that people miss a lot, and it has to do with clocks. And I can't remember if it's in that video or the RS-232 video, but I'm pretty sure it's in that one. And people miss this a lot. They think that your clock is aligned with your bits, right? Like, so your clock will rise with your bit rise, and it doesn't. Your clock will almost always be about 90 degrees out of phase, so that clock transitions, or when you sample for data, are going to be in the middle of a bit, right? So if you have the reason that's important is because if you have long lines or noisy lines or degraded lines in one way or another, your data is not going to look like a square wave, right? Like it's going to look like a little gimpy sine wave sometimes, for lack of a better phrase, right? Like it's going to be
Yeah.
poorly, where the rise time won't be clean, the fall time won't be clean, and stuff like that. So if you try to sample outside of that kind of mid bit period, you're like considerably more likely to get errors and stuff like that. So In a perfect world, your rise times on your clock line and your rise times on your data line are going to be maybe aligned, but in reality you'll always find that they're 90 degrees out of phase. And he kind of talked about that, and it's one of those things that unless you dig down into it and you start trying to talk to something, like write your own interface, you're not going to think about that stuff, unless you're a guy trying to troubleshoot like a bus with a logic analyzer or something like that. You're just not going to see it.
Right. Right. And at the start of something like that, you might not necessarily know where the path is going to take you, or you might not appreciate kind of the journey that's ahead of you. But I almost always walk away with something like that, even if I don't actually complete the thing, with a newfound either understanding of what I'm getting after, or a newfound appreciation for the people who made it in the first spot, and how much time it probably took them to be able to, come up with something that worked, and worked consistently, and worked under a lot of different conditions. Anyway, it's I thought that video was an absolute pleasure to watch. The fact of the matter is that you can go to school, you can buy somebody's book, you can, look up some YouTube videos and stuff, but you cannot, absolutely cannot buy the knowledge that's gained through firsthand experience. There is no substitute for it. And while this show aims to help people build their tool sets out, it doesn't aim to give people the drive to be able to keep after those experiences when they don't go your way, or when something seems too confusing to you. I know that there are certainly things that I can get into now that I looked at like I was standing at the foot of a mountain, 10, 15, 20 years ago. And you kind of forget a point in time where you didn't know something. So, what am I getting at here? The point is to just get after it, go after things, try to get your hands a little bit dirty in some of them. And check out that video, man, because it's a great video to watch. Any thoughts on that?
No, I think that pretty much covers it. I think that pretty much covers it. The firsthand experience is always, I think, going to be pretty much the best, no matter what you do. It's You're not really going to be able to get around that. Just reading a book is pretty much never going to be enough. That's going to get you like the right direction. Maybe knowing some of the nomenclature and stuff like that, understanding the theory and things, but like that practical implementation in the real world where you know you're not trying to figure out what the whatever of a cow is, but except it's a fucking sphere in a vacuum. You're never going to get any of that like real world experience and that idea of what's going on without just digging down into something and fucking it up a lot, just over and over again.
Yeah, absolutely. I love the video, love what it has to say. Hopefully, we get into some more of that here on the show too, and other things for other people to dig their teeth into on that front. I think it's a good probably point to recap, I guess, what we had talked about on the last show, and then get into what we're aiming for the next one. So, in the last episode, we had talked about investigating some chips, and a couple of different websites came up that we talked about. Some of the ones that would be good sites to go out there and grab some manuals from. If you can get identifying marks on the device and there has been no sandpaper used to rub off any of the information, or epoxy used to try to pot a piece and make it really hard to get at, getting the information from it is going to be key, because as pointed out, what we were just talking about with the timing diagram, if you have one of those data sheets readily by your side and you have that timing diagram, then you're going to be able to have answers to questions for why, pin whatever, pin 6 or pin 5 is tied to ground. Without that data sheet, you might be scratching your noodle thinking, what's going on there, because you don't have true insight to the chip. So data sheets are essential to be able to help both with questions like, why is this configured this way? And when it comes down to memory mapping, when you finally get to the point where you're pulling off, the programming of the actual chip for the embedded device, and memory maps so that things can be really reloaded to Ghidra in the right place, and all of your references worked up to look correct and not just kind of like spaghetti. After we talked about some of those areas and some other places to look to, I believe that you and I were recently talking about this, Dell, and you'd brought up the EEV blog as sometimes a good place to just ask some questions if you're not having any luck with your Google foo.
Yep. I don't remember on what account or anything like that, but I think I have a couple of posts on there like, hey, have you guys ever heard of this really weird part, or what have you? And some folks won't necessarily say in public, but I think sometimes in the old DMs you'll
Right,
maybe get some gems on occasion as well.
right. right? Or if somebody happens to have worked with it too, but they signed an NDA, sometimes there's some kind of bro deals or something that goes on and saying like, hey, I've been there. Yeah, here's a thing, or here's a place you can look for that thing. And if it's old, it's almost always the Wayback Machine and hope for the best. Hope they were captured on that day. So in addition to talking about identifying some of the places where you can find, things about chips, there was also talking a little bit about some of the kit inside of the show notes for the last one. I ended up throwing up a section on using a C232 HM cable, which supports JTAG, SPI, and I2C, installing libmpsse. And I didn't get to the part in that section where I was talking about programming up or using the TL866, but that one will be coming out soon. Also, too, you've used the open source programming quite a bit, correct?
I have used it. I haven't used it lately, so I've sort of forgotten a little bit about what exactly a pain it may or may not be to use, but I have used it in the past on my Linux computer to run the software.
Yeah, the infamous John McMaster is I think it's out there on his GitHub. I'll make sure to include that in the show notes too. But if you don't feel comfortable using the software that comes with it, and I don't blame you, that is one
Right.
option that you can take a look at. Most things these days for me, if they're small enough, are going to be run through Virus Total, but sometimes you just still get those heebie-jeebies for whatever reason. Thankfully, there are heroes out there like John McMaster who take the time to be able to do some of their own RE work to understand how to talk to the thing, or they get the software and they RE that, and then they figure out a more transparent open source way to be able to interact with the thing. I'm a big fan of those projects, and so I will definitely make sure that that's shared. So in the next section, though, after it is that you do get some of those loadouts from that firmware off, again, the video with Ben Eater pulling that off and realizing that the problem wasn't for programming for the device, but rather it was what was pulled to look up those, I guess, is just like a lookup table, if you will, for all of the word substitutes. It may be that
Yeah.
there isn't program loadout on there. It's data. You have to get out understanding what that data actually means. Most of the time, it's going to be stored right as binary. It's not as if it's going to be stored on a flash chip as a Word document that you're going to be able to just read straight away. You're going to have to figure it out.
Yeah, I mean, so and I think kind of like we saw here, the first thing you need to figure out is this instructions, right? Is this code that I'm looking at, right? Is it something the device actually executes, or is it something like configuration or a support device in some way? Like he found this one was in that case. It's just like, oh, this is full of ASCII. Man, that is so lucky. I
Yeah.
cannot. I think of a time I've ever just dumped an EEPROM and it's been full of ASCII. Like never.
Yeah, agreed. Pretty lucky. I mean, for the most part, these days, a lot of people use some sort of binary format, and whether that be in a message that's going back and forth between, an MCU and some other piece of hardware, even if it's over something common, there's going to be a little bit of decoding process that you have to figure out. So yeah, I think I agree with you. That was pretty interesting that it came out that way straight away, and it had even had like a version number on it too. So that they could just, I guess, swap those out potentially if they had another updated list of like kind of dirty words or subwords or something like that. Thought that was very interesting. But for the most part, then when you're trying to see if it's instructions or not, it may be instructions, but there may be some instructions and then something else. And that something else could be a first stage bootloader. It could be a real time operating system. And there are a couple of usual suspects in that space like QNX, VxWorks, FreeRTOS. Am I missing others?
That's all the ones that I know about.
Yeah, there's probably some more, but any of those all have their own issues that you have to get past. And they could be zipped. In what way are they zipped? Are they zipped kind of a traditional way? Are they using something like JFFS? Binwalk is usually your friend, but sometimes Binwalk fails. You just have to know about some of those standards, or you might need to ask around. And then after you kind of sort that all out and you carve out the pieces, you also have byte ordering issues you could run into. At that point, you might be getting to the stage where you're starting to be comfortable in loading that in a Ghidra, or maybe you loaded that in a Ghidra to start with just to see if it automatically identified what you had. I've done both. I continue to do both. if you have been able to find data sheets for whatever chip it is that it's off of, chances are that you're going to be in a pretty good spot, because from those data sheets, you're going to be able to at least understand what architecture it is. Like, let's say it's ARM, 32-bit Little Endian. There's going to probably be reference to that somewhere in the manual. Even if it's not showing up in Ghidra, if it's showing up just as, oh, this is raw, I couldn't identify what it was, you might just go ahead and do the drop down to select what you've read in the data sheet, and then hope it's able to get some level of fidelity into the code that way. Trial and error as well as educated guesses. It's a lot of
Yeah,
seg faulting to
and
success,
nothing's
as
going to
it
beat
were.
experience there.
Right.
Right. It's like when you're trying to compile something that doesn't come with very good instructions, and you just keep trying to learn which library you need to download next.
Yes, you just play whack-a-mole with dependencies. You get a little bit further and the
Yeah.
compilation fails.
So, I think it's kind of important to note there. One of the things that really complicates things is I think making the jump to embedded stuff that makes it more difficult is because, like, on a computer, you can usually tell, right? Like, if you file something or even look at it in hex editor or something like that, like elfs for an operating system, they conveniently say elf at the beginning. You know what I mean?
Right. Or
And
MZ for
there's
Windows
nothing like
executable.
that for embedded stuff. Exactly.
Yeah.
There's nothing like that for embedded stuff. Like ARM code doesn't start with ARM. ARM code starts with a vector table, and good luck, right? Like
Right.
you got to figure it out from there and hope that you get some of those things that you were talking about correct along the way. Otherwise, you're just going to be kind of floundering in the dark.
Yeah, and two, while the memory you're pulling from might be contiguous memory, that doesn't mean that that contiguous memory is all the same contiguous data. Like I had mentioned before, there could be a beginning section, which is an initial bootloader, followed by the actual code, followed by some other data that's a lookup table or something. And all of that kind of maybe gets loaded into different areas of memory for the MCU and or other, RAM blocks and things like that. So sometimes
I
you don't necessarily have that all readily available to you, but if you can find something like a UART, which is sometimes giving you a stream of information, if it's using an RTOS as well, there may be a stream of information you can get via the UART that will tell you where things are getting loaded, or at least the base address, so that it can be loaded correctly for you in Ghidra.
Also, if you do have some data sheets, this could be a good place to look and even see if your device could be code. Not every device supports having code not on chip. You know what I mean? So
Yep.
if your device doesn't have any ability to say respy flash and then load that as code, then you know that you're not going to be trying to look for instructions and stuff like that. And in that particular place, you're going to have to do some RE work to find out exactly what the bit boundaries are and things like that inside of there to have any idea how to start taking a look at that data.
Right. Right. So that's kind of that's a recap, kind of what we talked about in the last episode. And the goal here for the next one is to get more into that. Okay, well, I've got some stuff that I'm looking at now. What do I do with it? And have a couple of little chips that we were taking a look at, but we're always looking for more. So if you have something
If you've got
interesting,
good ideas on how to pick up random electronics that nobody wants, send us those ideas
yeah, absolutely.
because we'd like them.
But yeah, like I said, I think that's probably going to be it for this episode. Keep it relatively short, short for us.
I'm gonna say relatively short. It's just really not our gig.
Yeah. Okay, so I think that's going to wrap it up for this episode. I think the next one here we'll probably aim for having out in maybe, what would you say, probably early December, mid December?
Yeah, that sounds about right.
And then maybe we'll get another one in here at the top of December, or one maybe to start off the new year. All right, well, thank you guys for listening, and we'll see you next time.
Have a good one.
Repp.show. Nerd Talk IO.